Okay, so in the afternoon we're going to talk about decision theory, but I'll just kind of introduce it a little bit here. So when we're applying Bayesian networks, we often got problems where we have we want to get we have a lot of uncertainty in the system, and we actually want to get it right, make sure. So we've got a few examples here, and I've done projects on most of this stuff. So you guys are going into this stuff here, which I haven't done beforehand, but environmental management on species extinction, we've done a lot of projects on that. We've got the uncertainty and the complexity of the ecosystem there, and there's a lot of difficulties on how do we value a species extinction versus a reduction in agricultural output or something like that. So we have these types of problems for that. Weather forecasting, so we've had projects on fog prediction for Melbourne Airport, where planes might crash and lives might get lost. There's medicine. I'm doing one for a project for the Melbourne Sexual Health Centre on STDs, which is fun. Law stuff, space shuttle explosions, hiring people. We might get wasted money and whatever. So when we want to make these decisions under uncertainty, we want to work out what different types of a set of actions, what actions should we take in that. And the Bayesian answer for that is that we try to find a solution that maximises the expected utility. So have people come across the concept of utility before? So for one of our examples that we'd often use is with global warming. So we have some probability of the global warming hypothesis being true or not, and we've got different types of actions here. And within each of these different possible worlds, so global warming is happening, and we did nothing, there's some expected sort of value in that world. That's a pretty bad place to be. We don't do anything, although that's one where we seem to be heading mostly. There might be global warming happens and we do something to actually curtail it, so we might be negative but not so bad there. And global warming might not happen and we do something about it, and we've got some unnecessary costs that we've put into actually mitigating the global warming stuff. And the way we do this is we work out the expected utility for each of these different actions. So the expected utility of doing nothing is going to be the probability that global warming is happening times the utility that we did not here, plus the probability that global warming isn't happening times the utility here. And then we do that for that. So we get an expected utility, expected sort of world, which is weighted for the utility based on the probability there. And then we do the action which is maximising that expected utility. Now we're going to talk a lot about that after lunch. So I suppose the point that we come out of this one is, so when we did that exercise about the cancer clinic, I don't think anybody guessed that it was lower than 10%. Some of you got a bit closer to it. That's common. It's really well established that we're just not very good at doing this type of calculations in our head. So that's why we go and do stuff like using these pen and paper and actually writing down these calculations on these whiteboards here, using these frequency formats here, which is, well, this is better here. I mean, it's better because it's easier to look at and understand than that thing there. But when we get a more complicated problem, it becomes a lot more difficult. Or we can use Bayesian networks, which is what we're going to do today. But we need a computer for that, obviously. Now, how are people going? So I mean, there's a little bit big, just bringing up a whole lot of those probability concepts here. I'm not certain how important those are for different people with different roles in the project. You're going to be using these probabilities more than others, right? But the main point, the main motivation for this section of the training is just to give you that background of what the actual science is behind it. So, does anybody have any questions, or you're all good?
Can you just go back to the previous slide?
This one?
Yeah, so what approach does Netica use, for example?
Sorry, come again?
What approach is Netica based on, for example?
Well, Netica is essentially using, forward chain rule for going predictively down through the network and Bayes' theorem through this. So it was basically an application of this Bayes' theorem here. But it's doing it all in the computer, and the computer's doing all the handling of carrying the wands and stuff like that and pushing buttons that we don't have to bother with. All right, okay. Stephen, can I get you to... Oh, sorry, another question?
Just for the PE down.
Yeah.
So the bottom line, because you have to put the evidence, the H and H bar, because it's dependent.
sorry, the H, so were you talking about my notation that I've been using there?
Yeah, I mean, you have to multiply. I mean, you want to have the full probability for P of E.
Yep,
Yeah?
yep,
And you have to find it with the fact that you can have H and
yep.
non-H.
So I'm using the numbers that I've got here, and the probability of the evidence world is we know all these different situations when we are. So we know what's the probability that we're going to be in this not have cancer world, and probability that we do have cancer world, and then given that, we look for those different types of situations when we actually have the evidence.
So you have to enumerate all
So we had cancer and the evidence there, and we don't have cancer and the evidence there, and that's our full evidence space for having cancer.
So you have to enumerate all the possibilities.
Yeah, that's right.
You
Yeah.
have a table of
Yes,
all
yes.
the case of the table.
Yeah, yeah, that's right. Yeah. Okay. So back in the last slides, we had a picture of Reverend Thomas Bayes. So for Bayesian Networks, our picture that we put up is Judea Pearl, who I think actually looks a fair bit like Kevin, actually, as well. So he's the guy who first wrote, the book on Bayesian networks. And if you're particularly that way minded, you might go and read it, but he's very mathematical, and there's more accessible books to Bayesian networks. But if you're going to go really deep into it, you'll go into his book. He's still around doing presentations and stuff as well. I haven't seen him, but it'd be really cool too. So now in this section, before over the next little bit, I'm going to be talking about Bayesian networks and what are actually the syntax for the Bayesian networks here. So we start off with a definition for a Bayesian network. So a Bayesian network is a graph which has a set of random variables. We have a set of directed links between those variables. We have for each of the variables has a conditional probability which quantifies the relationship between it and its parents. And also a Bayesian network has to be a directed acyclic graph.